Hi, in this lesson we'll check out the two-step equations. We've looked at one-step equations where we need to add or subtract or multiply or divide to isolate the variable. Now we're going to do two things. We're either going to add and multiply, subtract and multiply, or add and then divide, or subtract and then divide. On paper, this might look strange because it's the opposite of BEDMAS, where we add or subtract first, and then we multiply or divide to isolate the variable. But not to worry, it actually feels quite natural when we see where the variable is and decide how to do things. The order will become pretty straightforward. When we have a question like this one on page 204, what we need to do is focus in on the variable, like we did with one-step equations. We see the variable is here with the 2x, and then we see we have 2x plus 4 is equal to 10. So what we're going to do with this equation is we're not going to try to isolate x yet because we have something else. So we're actually going to do what's furthest away from x first. We're adding 4 to 2x, so we're going to get rid of the 4 first. We're going to subtract that 4 away on both sides of the equation, canceling it on the left, leaving us with 2x. So we're getting closer to isolating the variable, but we move everything that's furthest away from the term with the variable first. 10 minus 4 is 6. And now we can isolate. We're multiplying 2 to x, therefore we're going to divide by 2 on both sides of the equation. That cancels on the left, x is isolated, and 6 divided by 2 is 3. X is equal to 3. Let's look at a couple more examples. Remember, we are going to move away any terms that are not including the variable, and then we will deal with the variable term last. So we have negative 5w minus 7 is equal to 23. So we're going to get rid of the second term. The minus 7 is going to go away because we're going to add 7. We'll do the inverse there, canceling, and we do the same on the other side of the equation. Negative 5w is equal to 23 plus 7, which is 30. And now we can isolate w. We're going to divide by negative 5 because we are multiplying to w. So we divide, canceling, and we divide on the other side. W is equal to 30 divided by negative 5. W is equal to negative 6. For this next example, we have h over 8 plus 6. We cannot touch the term with the variable until we get rid of any terms that are added or subtracted to that. So this plus 6, this has to go away first. We're going to subtract 6 from both sides, canceling here. Now we can isolate the term where the variable is. H over 8 is equal to negative 11 minus 6. Be careful here, you may need same, change opposite. That's negative 17. So now we've isolated the term where the variable is. We are going to now isolate the variable. We are dividing h by 8, so therefore we're going to multiply by 8 on both sides of the equation. So we're going to cancel over here, put my answer across. So h is now isolated, and we're going to take the negative 17 times 8, and that is 136. That's going to be a negative 136. Let's do a check here. Remember, you can check in the original equation, I'm going to take 136 negative over 8 plus 6 is equal to negative 11. I'm going to take my calculator and I'm going to work that out and see if that works. I'm going to use brackets here, just good habits. So negative 136 divided by 8, just to check it, that's negative 17 plus 6 is equal to negative 11. Negative 17 plus 6 is negative 11. So this checks out. I know I have the correct solution for H. All right, let's keep going. We have 12 minus G is equal to negative 8. Again, we can't do anything about that G term until we get rid of the other term. So we have a positive 12 here that we need to move out. It's positive, so therefore we're going to subtract 12. 12 minus 12 is nothing, and we're going to subtract 12 to the other side. That's going to leave us with negative G is equal to, and now we have negative 8 minus 12. Again, this is where same change opposite really comes in handy. So that's going to be negative 20. And so on the surface, this looks like a one-step equation, but it isn't, because we cannot have a negative variable as a final answer. This is negative G. Well, what does negative G mean? Negative G means negative 1G. That's a coefficient. So we can isolate G, having it as a positive answer, which is what we need, by division. We're multiplying the negative to G, so we're going to divide by negative 1. And we're going to do that on both sides for balance. Now we have G as a positive. G is equal to negative 20 divided by negative 1, which is positive 20. Now shortcut, if you're comfortable, anytime you get a negative variable answer, negative G is equal to negative 20, understanding that what we're doing is really a fast way to divide by the negative 1, is what you can do is switch the signs. So you can say, I have a negative variable answer. Let me make that variable positive, and then let me switch the sign of the answer to its opposite. So where we had a negative 20 becomes a positive 20. So you can do that, but understand that that's a quick way that what negative G means is that's a coefficient that needs to be divided out. So let's do one more on this page. 3 minus 2x is equal to negative 15. We can't touch that 2x. All we can do is get rid of the other term first. Again, we have a positive 3 here that we are going to subtract away. We need to do that term first. So we're going to subtract 3 on both sides. That's going to leave us with a negative 2x is equal to, and again, same change opposite may be helpful. Negative 15 minus 3, we add the opposite. That's negative 18. Here, we now have negative 2 multiplied to x, so we need to do its opposite. We're going to divide by negative 2. On both sides, canceling on the left, x is isolated. Negative 18 divided by negative 2 is a positive 9. X is equal to 9. And you can substitute that into the original equation, and you will see that you will have balance. The next example is a little different from the other ones. This looks like a one-step equation, but it isn't, because we have a variable down here in the denominator. We have 12 over a is equal to 3. how are we going to isolate a? We are not doing anything to a. A is down in the denominator. So what we need to do here is actually get a out of the denominator. We need to get a out by multiplying it. It's being divided there. So we're going to multiply by a on both sides. And I'm going to show that with a raised dot just to show it. So it may seem funny, but we're going to get rid of a on the one side, leaving us with 12. And we're going to multiply on the other side. 3 times a is 3a. And now we've gotten that variable out of the denominator. Now we can isolate it. So we're going to go ahead now and divide by 3 on both sides. And that is going to be 4 is equal to a. So when you have a variable in the denominator, you need to move it out through multiplication, and then you can isolate it. The last example in this video is on page 207. This is one of the student examples. Here we have a fraction. 2/5 t plus 3 is equal to 11. We can't touch the term with t in until we get rid of the other term. So we're going to subtract the 3 from both sides first, leaving us with 2/5 t is equal to 11 minus 3, which is 8. You may recall with one-step equations, now in order to isolate t, what we can do is we can actually go ahead and multiply by its reciprocal. You can divide by 2/5 as well, but a bit faster is recognizing that we can multiply by the reciprocal of the fractional coefficient. That will cancel it out right away. So t is equal to 8 over 1 multiplied by 5 over 2. I'm going to cross reduce here, divide by 2, divide by 2. My denominator is now at 1, so I can drop that. 4 times 5 is 20. And you can check this. 2/5 times 20 over 1 plus 3 is equal to 11. Again, fractions. 5 divide. 20 divide by 5. 2 times 4 is 8. Plus 3 equals 11. 11 equals 11. We have a balanced equation. So you can try the other student examples and the exercises for this lesson on page 208 and page 208 up to page 212 for the two-step equations.